Hi, and in this section, I will be solving trigonometric equations using the unit circle and trig identities. So there's no formulas we really have to go over. It's just old formulas that in your previous section. So yeah, so we're going to be solving trigonometric equations. So let's start with example one. Example one says solve sine of x plus square root of 2 equals negative sine of x. Okay, so what I first want to do is try to get x by itself. That's the first thing I would do. So the first step is maybe I can move this radical 2 to the right, right? Or no. Yes, that's what I would do first. And then, no, I would get one side 0, so I would add sine x to both sides. Okay, so when you add sine x plus sine x, you get 2 sine of x plus radical 2 equals 0. Then what I would do is to get, because I eventually want to get x by itself, I would subtract radical 2 from both sides. So this cancels. So you have 2 sine of x equals negative radical 2. Then I would divide both sides by 2. I want to get rid of this 2. So divide by this. So you get sine of x equals negative radical 2 over 2. Okay, so you can actually stop here. Or you can make, what this really means is you could actually stop here, or even though I didn't talk about inverse, you can take, to get x by itself, you can take the sine of inverse of both sides. So when you, on the left side, when you multiply sine with sine of inverse, this cancels, so you're just left with x. And then on the right side, you're just left with sine inverse parentheses negative radical 2 over 2. Okay, so what they're really saying is what degrees in radians is going to give you a sine of negative radical 2 over 2. So it's good to know your unit circle. So here, let's do that. So where is sine negative? It's not in quadrant 1, it's not in quadrant 2, right? They're both positive. But sine is negative only in quadrant 3 and quadrant 4. Okay, so in quadrant 3, it would be 5 pi over 4, right? Or I think it's also the same thing as 225 degrees, if you like degrees better, because 5 pi over 4 has a coordinate of negative radical 2 over 2, comma negative radical 2 over 2. And if you recall, that sine is also this y value, same thing as the y value. Okay, so 5 pi over 4, and what else? 7 pi over 4, right? 7 pi over 4 is the same thing as 315 degrees because it has a coordinate of positive radical 2 over 2, comma negative radical 2 over 2. Okay? Because remember, sine is the y value. So they want to know all the solution because they don't give you boundaries. Usually if they give you a boundary, it's like 0 from 2 pi, they give you a boundary. They don't. So they want all the solution. So all the solution would be, well, for this part, there's two answers actually. One of the solutions is going to be x equals 5 pi over 4 plus 2 pi k. So why did I add 2 pi k? Well, because they say all the solution, there's no boundaries. So what this means, like, let's say you had, well, if you want, you could put this in degree mode. This is the same thing as 225 degrees plus 2 pi is the same thing as 360k. So you can put it like this if you want. But let's say the k represents how many times you're going around the unit circle. So let's say you add 1k equals 1. So if you did that, that would be 225 plus 360, which would be 225 plus 360 is 585 degrees. So this means is like if you go 585 degrees in the unit circle, so that's at least twice going around the unit circle twice, right? You would still be in the same place here. And that's why I put the k, because they want all the solutions. There's no boundaries. Okay, same thing with this answer, because you could do x equals 7 pi over 4 plus 2 pi k. Or you can say that's the same thing as, if you want it in degrees, it's 315 degrees plus 360k. So either answers would be okay because they're the same thing. Okay, let's move on to example 2. Example 2 says solve 3 tan square x minus 1 equals 0. So just like the last example, you want to get x by itself. So first thing I would do is add 1 to both sides. So this cancels. So you have 3 tan square of x equals 1. Then you would divide both sides by 3. So you would get tan square of x equals 1 over 3. And then what you're going to do is you're going to take the square root of both sides. So this is going to be tan of x. Now be careful, when you take the square root, you get two answers, right? You get a plus or minus. And just let me so how do you simplify it? This is square root of 1 over 3 is the same thing as square root of 1 divided by square root of 3, right? You should rationalize the denominator, so you would multiply top and bottom by radical 3. So radical 1 times radical 3 is radical 3, divided by radical 3 times radical 3 is 3. Okay, so this is like saying tan of x equals plus or minus radical 3 over 3. And if you can stop here, some people already know that where is this going to give you tan of plus or minus radical 3? Or you can take the inverse. If that confuses you, take the tan inverse both sides. So this would be x equals tan inverse of plus or minus radical 3 over 3, right? Okay, so this is where you're going to need your unit circle. So get out your unit circle. And then where is tangent? So we have two answers, right? A positive radical 3 over 3 and a negative radical 3 over 3. So where is tangent going to be positive and negative? Positive radical 3 over 3 and negative radical 3 over 3. So it's going to be, our only possibilities is in quadrant 1 and in quadrant 2, because quadrant 3, quadrant 3 would be positive. And so it's going to be pi over 6 and 5 pi over 6, right? Okay, because pi over 6 has a coordinate of radical 3 comma 1/2. And then 5 pi over 6 has a coordinate of negative radical 3 over 2 comma 1/2. And if you call remember this is your x, this is your y. If you recall, tan is the same thing as y over x. So if you did 1/2 divided by negative radical 3 over 2, you would get negative radical 3 over 3. And if you took here, if you took the tangent of that, of pi over 6, that's going to be 1/2 divided by radical 3 over 2, which will become positive radical 3 over 3, right? Okay, so once you know that, we don't have any boundaries, so we have to use all of our answers. So one of our answer is going to be x equals pi over 6 plus pi k. Now, there's a reason why I use only pi k, and like unlike the other problem, I use 2 pi k. Yeah, the reason why I use pi k is because if you plug in k for 1, so if you did pi over 6 plus pi k plus pi, you would eventually be in this point, right? You would be here. And that's why I'm going to use pi instead of 2 pi k. So that is a bit confusing, but that's why I use pi over k. And the same thing with 5 pi over 6. So the other solution would be 5 pi over 6 plus pi k, not 2 pi over k, because, oh, that was, so, okay, so, yeah, so that was pi over 6. So if you did, if you added k for 1, you would eventually end up here, which is technically the same answer. So the same thing with this one. If you did the 5 pi over 6 plus pi over k, and you add, and you say k equals 1, you would end up here. So that's why it's going to be pi over pi instead of 2 pi over k, because you're moving 180, so you'll eventually end up in the same place. So that can be a little bit tricky. Okay. Example 3. Solve cotan x cosine square x equals 2 cotan x. So what would I do first? I would get one side 0. So I would subtract 2 cotan x on both sides, right? So this becomes 0. And then over here, you're left with cotan x cosine square x minus 2 cotan x, right? Okay, so what would I do next? I have cotan x times cosine square x minus 2 cotan x. Is there anything I can take out? I can, right? And what would that be? That would be, looks like I could take out 1 cotan x. So this would be cosine square x minus 2 bracket equals 0. Now from here, you can actually we have 2 equations now. You can set each equation to 0 if you want. So what it means is you can set the cotan x equals to 0, and then the other equation would be cosine square x minus 2 equals 0, right? And then from there, you can just get x by itself. So you could take the cotan inverse. For this part, you could take the cotan inverse both sides. You would get x equals cotan inverse of 0. So what they're saying is what degree in radians is going to give you a cotangent of 0. And if you recall, cotan is not the same thing as tangent. It's the opposite. So cotan is x over y, right? So I think the only choice would be pi half, because pi has a coordinate of 0, 1, right? And if you did the x over y, so that would be 0 over 1, that's going to give you 0. Anything else, like if you did pi or 3 pi halves or even this 2 pi, it would not give you 1. I mean, it would not give you 0. So so this solution is going to be x equals pi over 2, or you could do 90 degrees, it's the same thing, plus pi k. And the reason why I use pi over k, because if I do let's say if you said k equals 1, you would be right here, right? So that would be the same thing as 3 pi over 2, and that would be 0, negative 1. You would still get the same, you would still get a cotangent of 0. So yeah, that's why I'm going to use pi over k, because you have, if you go 180 degrees, you would be here and you would still get a cotangent of 0. Okay, now let's look at our other problem, our other equation. So if I would add 2, I would get cosine square of x equals 2, right? I would take the square root of both sides, right? So I would get cosine of x equals plus or minus radical 2. You could get x by itself by taking the cosine inverse. So that would be x equals cosine inverse of plus or minus radical 2, right? Now, is this even possible? No, right? There's no, if you look into your unit circle, there's no, the answer will give you a cosine of positive or a negative radical 2 over radical 2. You do have a possibility radical 2 over 2, but not just regular radical 2, so this is not possible. Okay, so your only answer is going to be this. X equals pi over 2 plus pi k. Here's example 3. Let's move on to example 4. So find all the solutions of 2 sine square x minus sine of x minus 1 equals 0 in interval from 0 to 2 pi. So that's the same thing as 0 bracket 0 to 2 pi parentheses. So this one actually has a boundary. That's good, because that means we don't have to do the pi k anymore. So first thing I would do is looking at, well, we have one side 0, so that's good. So here's our solution, our equation. What would you do to get x by itself? So first off, check if you can factor anything out. We have 2 sine square x minus sine x minus 1. We obviously can't take anything out. So the next thing I would do is do factoring. So what factoring method would you use if you have a coefficient other than 1 of the highest degree? I would use, that would be, it's the AC method, right? Or the bottoms up factoring. So yeah, we're going to do that. So the first step of the AC method or bottoms up factoring is rewrite the equation as if the 2 doesn't exist. So it's going to be sine square x minus sine of x minus, now you're going to multiply the 2 by the negative 1. So that's negative 2 equals 0, right? Then from here, you can actually do just regular simple factoring. So this would be sine of x, and then this would be 2 and 1. And then from here, I need two numbers that are multiplied to give you negative 2 and added gives you negative 1. So I would use negative 2 and then I would use positive 1, right? And then remember the 2 from the original equation, you're going to divide this negative 2 by the positive 2 and then this 1 by the positive 2. So this simplifies as sine of x. This would become negative 1. And then over here, this 1/2, it can't be reduced. So this is what you're going to bring the 2 in front of the sine of x. So that would be 2 sine of x and leave the numerator alone. So it's just plus 1 equals 0. Then you can set each equation to 0 and then solve for x individually. So go ahead and do that. So first equation would be sine of x minus 1 equals 0. And then my other equation would be 2 sine of x plus 1 equals to 0. Go ahead and add 1, add 1. So this would be sine of x equals 1. You could stop here, or you can do one step further, taking the sine of inverse of both sides. So this would be x equals sine of inverse of positive 1. And then over here, you're going to subtract 1. You're going to get 2 sine of x equals to negative 1. Divide this by 2. Divide this by 2. You would get sine of x equals to negative 1 over 2. Okay? And then if you want, you could get x by itself by taking the sine of inverse. So this would be x equals sine of inverse of negative 1/2. Okay, so we have two solutions from 0 to 2 pi. So this is where you're going to need your unit circle. So let's start with this part. Where is sine going to give what degree? So what this thing is, what degree in radians is going to give you a sine of positive 1? Sine of positive 1. Wouldn't that be, there's only one choice, that would be pi over 2, right? Because pi over 2 has a coordinate of 0, 1, and remember, sine is the same thing as y. So one of our answer is going to be pi over 2, or you could do 90 degrees. Do not use 3 pi over 2 because that has a 0, negative 1, so that won't work. Okay, so now the next one is where it's going to, so I'm talking about x equals sine inverse of negative 1/2. So what this saying is what degree in radians is going to give you a sine of negative 1/2. So where is sine negative? In quadrant 3 and in quadrant 4, right? So in quadrant 3, I think we'll use exactly 7 pi over 6, right? Because that has a coordinate of negative radical 3 over 2, comma, negative 1/2. So one of our answer is going to be, other answer is going to be 7 pi over 6, and do not use plus 2 pi k or any kind of k because we have a boundary from 0 to pi. And then what's the other, where else is sine negative 1/2? 11 pi over 6, right? 11 pi over 6, because that has a coordinate of radical 3 over 2, comma, negative 1/2. So sine is negative 1/2. So our other answer is going to be x equals 11 pi over 6. So you have exactly 3 answers. Okay, I hope that helps a lot. Okay, so that was example 4. Let's move on to example 5. Example 5 states same thing, solve 2 sine square x plus 3 cosine of x minus 3 equals 0. So at first when I did this, I thought you could factor, but it does not factor at all. Even if, yeah, it would not factor at all. So factoring will not work. So then what I did was use one of our identities. There is an identity, so I'm talking about this sine square x. It's one of your Pythagorean identities, and it's this one. Sine square of x plus cosine square of x equals 1. So to get sine square of x by itself, you would have to subtract cosine square of x from both sides. So you would get sine square of x equals 1 minus cosine square of x. So what you can do is replace sine square of x with this thing. So go ahead and do it. So 2, and then replace sine square of x with 1 minus cosine square of x bracket. and then just bring down the rest. So this is plus 3 cosine of x minus 3 equals 0. So then go ahead and FOIL and simplify. So 2 times 1 is 2. 2 times negative 2, 2 times negative cosine square x is negative 2 cosine square of x plus 3 cosine of x minus 3 equals to 0. And then just combine like terms. So I'm going to put the negative 2 cosine square first, and then the 2, and then you have the plus 3 cosine of x, and then you have the 2 and the negative 3, which is negative 1, equals to 0. Okay, then what I would do to make life easier is get rid of, I think I'm going to factor, but I want to get rid of this negative sign, so I'm going to divide everything by negative 1, including the 0, right? So this would be 2 cosine square of x, and then 3 cosine of x divided by negative 1 is negative 3 cosine of x. This would be positive 1 equals to 0, right? And then what factoring method would you use to solve for this? I would use AC method or bottoms-up factoring. So yes, first step, we write the equation as if this 2 doesn't exist. So it's cosine square of x minus 3 cosine of x. Then multiply the 2 by the 1, so that's positive 2 equals to 0. And then from here, we're going to factor. So this is going to be cosine of x, and then this is going to be 2 and 1. Then I'm going to use negative 2 and negative 1. Then what I'm going to do is divide this negative 2 by this positive 2. So divide this negative 2 by 2, and then this negative 1 by 2. So you get cosine of x, and then this is just negative 1, parentheses. And then this negative 1/2 cannot be reduced. So what you're going to do is bring the 2 in front of the cosine x. So that's 2 cosine of x minus 1 equals to 0. And then what you could do is set each equation to 0. So cosine of x minus 1 equals to 0. That'd be plus 1 plus 1. Cosine of x equals to positive 1. And then I guess you could take the cosine of inverse of both sides. So this is going to be x equals cosine inverse of positive 1. You could now do the same thing with the other equation. So you get 2 cosine of x minus 1 equals to 0. Add 1, add 1. You get 2 cosine of x equals to 1. Divide this by 2. You would get cosine of x equals to positive 1/2. Take the cosine inverse. You would get x equals cosine of inverse of positive 1/2, right? Oh man, I need more. Okay, so now what is our answer? So you might need the unit circle. So let me put the unit circle right here on the further left. Starting with the 1, where is cosine positive 1? That would be over here in 2 pi, right? Because 2 pi has a coordinate of 1, 0. Don't use pi because that'll give us negative 1. So one of our solutions is 2 pi. So where am I going to put the solution? Let me put it right here on the top because I don't have much space. So x equals 2 pi is the same thing as 0, so you could say 0 plus 2 pi k. Because now I use 2 pi k because it says all solution, and the reason why I use 2 pi instead of pi is because you have to go at least once around the unit circle, because if you did 180, if you did just pi, it would be right here. you would end up here, which would give us pi, and pi does not give you a cosine of positive 1, right? So yeah, okay, so that's one of our solution. Now, what about positive 1/2? So where's which quadrant is going to give you a cosine of positive 1/2? The quadrant 1, right? And that would be, what would that be? That would be pi over 3. And what else? 5 pi over 3. Where's 5? 5 pi over 3 would be in quadrant 4. So it would be right here. Okay, so my other two solution is going to be x equals pi over 3 plus 2 pi k. And the reason why I use 2 pi k is because it has to go at least one time around the unit circle to be at the original, to be back at pi over 3. So that's why pi wouldn't work. And then the other one is going to be x equals 5 pi over 3 plus 2 pi over k, plus 2 pi k. And the reason why I use 2 pi k, because you have to go at least one time around the unit circle to be at the same place at 5 pi over 3. Okay, so yeah, those are your three solutions. X equals 0 plus 2 pi k, x equals pi over 3 plus 2 pi over k, and then x equals 5 pi over 3 plus 2 pi over k, plus 2 pi k, not 2. Okay. Example 6, I think there's a total of 9 examples. So example 6 says, find all solution of this, cosine of x plus 1 equals sine of x in the interval from 0 to 2 pi. So we have a limit, so that's good. So what would I do? So let me rewrite it again here. Cosine of x plus 1 equals sine of x. Now, I tried subtracting sine x to get one side 0, and that didn't work out nicely. This one's a little bit kind of tricky because you have to think about it. You can't, if you can't take anything out. If you move something to the left, it still wouldn't matter. It would still be not factorable. So the last thing I did was I actually squared both sides. So when you square both sides, this is what you get. On the left side, you're going to get, this is squared, so you would have to FOIL it out. So that would be cosine square of x plus 2 times AB, right? So that would be 2 cosine of x plus b squared. In our case, our b is 1, so that would be 1. And then on the right, this is simple, right? If you square sine, that would be just sine square of x. Okay. Then what would you do? I would use my identity, right? I will not, I tried subtracting sine square of x on both sides. That didn't make it easier. It made it impossible, in fact. So I'm going to replace this sine square of x as using our Pythagorean theorem, right? Sine square of x plus cosine square of x equals 1, and then subtract cosine of x from both sides. You would get sine square of x equal 1 minus cosine square of x, correct? And then just replace the sine square x with 1 minus cosine of square of x. Okay. Then what you would do is continue trying to get this side 0, so you would subtract 1 from both sides. And then to get rid of this negative cosine square x, you would add cosine square of x to both sides. So this all cancels. So simplify, so cosine square x plus cosine square x is 2 cosine square of x plus 2 cosine of x, and then plus and negative becomes just 0, right? Equals to 0, and then what would you do next? I would factor, but always check if you can take anything out. Yes, you can. You could take out how much? You could take out 2 things. You could take out a 2 and a cosine x, right? So you could take out 2 cosine of x. This would be cosine of x plus 1 bracket equals to 0. And then what you could do is set each equation to 0. So you have two equations. You could do 2 cosine of x equals to 0. And the other one would be cosine of x plus 1 equals to 0. And then just go ahead and try to get x by itself. So you would divide this by 2. You get cosine of x equals to 0, and then you can take the cosine of inverse of both sides. That would be x equals cosine inverse of 0. Here, subtract 1, we get cosine of x equals to -1. And then you could take the cosine inverse of both sides. You get x equals cosine inverse of -1. So you'll need a unit circle. So good news is our boundary is from 0 to 2 pi, so you don't have to do the plus 2 pi k thing. So over here, let's try to figure out the x equals cosine inverse of 0. So what degree? So what they're saying is what degree is in radians is going to give you a cosine of 0. So that would be probably only be pi over 2, because that has a coordinate of 0, 1. And where else does cosine give you positive 0? 3 pi over 2, right? Because that has a coordinate of 0, -1. Okay, and then okay, so we did 0. Now let's do cosine inverse of -1. So what degree in radians is going to give you a cosine of -1? That would be pi, right? Because pi gives you a coordinate of -1, 0. Okay, so you have a total of 3 answers. So x is going to be pi over 2, 3 pi over 2, and pi. And that's it. You don't have to do the plus 2 pi k. Okay, that was example 6. Let's do example 7. Find all solutions to cosine 3t minus 1 equals 0. Okay, so we want all solutions, so there's no boundaries. So what I would do first is I would try to get t by itself. So I would add 1 to both sides. You would get 2 cosine of 3t equals to 1. Then I would divide both sides by 2. So this would be cosine of 3t equals to positive 1/2. And then I guess, now this one's kind of weird. I would get the cosine away first, because if you could factor out 3, or I would get rid of this cosine by multiplying everything by cosine inverse. So this cancels, right? So you get 3t equals cosine inverse of 1/2. Okay, do not divide 3 and then try to find it in your unit circles, because it won't work. So what I would do is just first find cosine inverse of positive 1/2 in your unit circle. So here's your unit circle. Where's cosine positive 1/2? So that'd be in quadrant 1 and quadrant not 2 or 3, but quadrant 4, right? That would be in pi 3. Yeah, pi over 3. So that has a coordinate of radical 3 over 2, 1/2. And then the other one would be 5 pi over 3, right? So that has a coordinate of 5 pi over 3? Yes. Yeah, my bad. Yeah, I was just thinking because I got confused with pi over 6. This is pi over 3, not pi 6. So this would, yeah, this would work. What I did, yeah, this is the wrong coordinate. This should be 1/2 comma radical 3 over 2. And then this would be positive 1/2 comma negative radical 3 over 2. So yeah, so your two possibilities, pi over 3 and 5 pi over 3. Now, remember, remember the 3t doesn't go away, so it's actually, so you could set this as, the first equation would be 3t equals to pi over 3 plus 2 pi k, right? Because they want all the solution. So here's pi over 3. If you go around one unit circle, you would end up at the same place. That's why I use 2 pi k instead of pi. Then to solve for t, you're going to divide both sides by 3. So you're going to divide the pi over 3 by 3, and then divide the 2 pi k by 3 as well. So when you simplify this, this would be t equals pi over 9 plus 2 pi k over 3. Okay, do the same thing with 5 pi over 3. So set this as 3t equals 5 pi over 3 plus 2 pi k, right? Don't use pi k because you have to go, if you start at 5 pi over 3 and then if you go around one time of the unit circle, you would be at the same place. Then divide both sides by 3. So you would get t equals to 5 pi over 9 plus 2 pi k over 3. So here is your two answers. Okay, so that's pretty much it. Okay, so let's do example 8 and then one more and then we're done. So example 8 says find all solution of 3 tan parentheses x over 2 plus 3 equals 0. So what would I do first? I would subtract the 3 from both sides. So this cancels, so you're left with 3 tan of x over 2. Then this becomes equals to -3 because we subtract 3 from both sides. Then I would divide both sides by 3. This cancels, so you're left with tan of x over 2 equals to -1. Then what you can do is get rid of the tan by multiplying everything by tan inverse. So this would cancel, so you're just left with x over 2 equals tan inverse of -1. Do not multiply everything by 2, and then you could do that later on, but for right now, go in your unit circle and figure out where is tan -1. So that would be in quadrant 2 and in quadrant 4. So in quadrant 2, it would be 3 pi over 4, right? And then because it has a coordinate of negative radical 2 over 2 comma positive radical 2 over 2, because remember, tangent is the same thing as x over y. And then the other one is at 7 pi over 4, because this would give you a coordinate of radical 2 over 2 comma negative radical 2 over 2. Okay, so what you would do is so let's start with the 3 pi over 4. So it's going to be x. Remember, this x over 2 doesn't go away, so it's x over 2 equals 3 pi over 4 plus pi over k. And the reason why I do pi over k like 180 degrees, because if you started here, 3 pi over 4, and if you moved exactly 180 degrees, you would be at 7 pi over 4, and that would still give you a tangent of -1. So that's why I use pi instead of 2 pi k. And then to solve for x, you're going to multiply both sides by 2. So this would be x equals 6 pi over 4 plus 2 pi over k. I mean, plus 2 pi k. And then this would be reduced to what? 3 pi over 2 plus 2 pi k, right? So that's your answer for this part. And then let's look at the 7 pi over 4. So still set it as x equals 2 because it doesn't go away. And then this would be actually, I think it stops just right there. Yeah, we don't have to do 7 pi over 4 because what we did is we did 3 pi over 4 plus pi over k. So this would still give you here the same answer here. So you don't have to do the 7 pi over 4. So yeah, this is your final answer. X equals 3 pi over 2 plus 2 pi k. Okay, and then let's do our last example. Find all solutions of secant square x minus 2 tan x equals 4. So this obviously does not factor evenly. So you're going to use what's called your identities. So this secant square x is the same thing as so it's one of your Pythagorean identity. So secant square x equals the same thing as 1 plus tan square x, right? So go ahead and replace that with 1 plus tan square of x minus 2 tan of x equals to 4. And then what you would do is get one side 0, right? So you can subtract 4 from both sides. So I would get 1 plus tan square of x minus 2 tan of x minus 4 equals to 0. And then when you simplify this, this would be tan square of x minus 2 tan of x. And then 1 minus 4 is negative 3 equals to 0. And then you could just do simple factoring from here. So this would be tan of x, and then I'll do negative 3 plus 1. And then go ahead and set each equation to 0. So tan of x minus 3 equals to 0. And then the other one would be tan of x plus 1 equals to 0. I would add 3 to both sides. To take the tan inverse of both sides. So that would be x equals tan inverse of positive 3. And then over here, you would subtract 1. You would get tan of x equals to negative 1. And then I would take the tan inverse of both sides. So you would get x equals tan inverse of negative 1. Okay, this is where you need your unit circle. So starting with the tan inverse of 3, what would that be? That would be oh, this would be tan inverse of 3 plus pi k. So I think that's just one answer. So that would be, it would be x equals tan inverse of 3 plus pi k. And then the other one is, where is tan inverse -1? So that's 3 pi fourth and 7 pi over 4. So you can remember, you don't have to put the 7 pi 4 because you can just say x equals 3 pi over 4 plus pi k. And yeah, you see the reason why it's plus pi k, because if you go 3 pi over 4 and then if you move 180 degrees, you would be here 7 pi over 4. So you don't have to do this 7 pi over 4 plus pi k again. You just leave it like that. Or you can say this is the same thing as x. This is what the book put. X equals negative pi over 4 plus pi over k, because plus pi k, because if you if you go negative 45 or negative pi over 4, you would be here. So that's the same thing as here. And then plus pi k, if you move 180 counterclockwise or even the other way around, you still end up here. So that's why you can leave it like that. Okay. I guess that wraps it up for this section. You have a great day. Bye-bye.